Hi everyone, so this is section 8.2, notes part 1, finding the area between two curves, and here's the formula. We go from the left to the right, and it's always the top function minus the bottom function, and we're integrating. So example 1, we integrated by hand and found the area of this region R. It's just 4, which is interesting. And then we went to example 2, and the first thing we had to do is find the intersection points here and here. We found the area of R and then the area of S, and those answers are here. And now we're going to answer part D. And there's an easy way and a hard way. And let me first show you the more difficult way, which is the way I did it at first. Thanks for being here. Here we go. Okay, so the more difficult way is if we break up this area of the unshaded region bounded by the graphs of F, G, and the x-axis. Here we'd start from the left, which we would start at 0, and then we would go to this point, and we would find the area under F, and that would be from 0 to our intersection point we found earlier. So the area under F plus the area. Now at this point, the graph switches to G. So now we have the G function from 0.178 to the number 1. So that would be like this. This is a harder way. Why am I showing you this? You need to know it. Okay, and then here we go back to F, and you would have to find that 0. And then you'd find the area from 1 to that 0, and we would add up these three areas. Okay, there's a shorter way, a shortcut, a little faster way. So the little faster way says we integrate this entire piece from here under this one function, because this is one function the entire time to here, and that is the function, I'm pretty sure that's the F function. And then we just subtract the area of S, which we found in part C. So that's what we're going to do. Now, what did I say earlier? We need this 0, which we had not found yet in the calculator. So I'm going to switch to the calculator. Here we go. And let's press house. Always do not use Scratchpad. Always go to a document, either a new document. I did the wrong thing, so I'm going to insert a new page. I want a graph. Okay, so I just need the graph of F. So 1/4 plus the sine of pi x. Is it going to do that for me? It did not like the way I typed that in, so I'm going to hit tab. Hi. Okay. Tab, I'm going to go up, and it just did not like that. So I need to go find pi. This is where you all were. Where's pi? Where's pi? There go my lights. Pi is down here. Pi is here. Okay, let's see if this works. I need enter. Ta-da. Okay, why does it look different? It's not zoomed in, so we can go to menu, zoom, and I think if you do it in the right spot, I did it 3 times. 1, 2, 3. And then we're going to go to menu trace, graph trace. There's our spider. We're looking for the 0. I hope I got this right. Yeah. And there you are. All right, 1.080. So for part D, we're going to say the area of the unshaded region is from 0 to 1.080. I'll switch to what I'm writing in a second. If I can figure this switching out. Here we go. Okay. So the area of the unshaded region will be the integral from 0 to this point here. This is the 0 under F. So that's going to be all of this. But then we still have to, we're going to subtract our answer to part C. Okay. So let's find this number in the calculator and then subtract C. Back to calculator. Yeah, I just want that. All right, I'm in a graph right now, but I need a calculator page. I clicked the wrong thing. Sorry guys, the buttons are hard to, I need control left. I don't think that's a calculator page. Insert page, add calculator. Here we go. All right, integral from 0 to 1.080. See, that's why we write it down. And then we have 1/4. Nope. Nope. Plus. All right, you're going to have to do all this, you know. Sine of, I just struggling here. There, I think that's going to help me a little bit. Okay. I just couldn't see the buttons, y'all. Pi, x. Okay, riveting stuff here. Watching someone else use a calculator. All right, that's the area under the function f, but then we're just going to hit the subtraction button, minus, and we're going to subtract our answer to part C, 0.140. That's the shaded region of S. So we found the entire region under that. It looks like a parabola. It's a piece of one. And that's the final answer, 0.486. So congrats, if you got the area of the unshaded region is 0.486. And you would have gotten the same answer if you had added up those pieces. Moving on. And here we go. What do we have here? We have another area R, another area S. We can do this. Picture to the right is the graph of f of x with this crazy polynomial, but then a cosine, and then the line L, which is tangent to f at the point 0, 3. All right, tangent, that's a key word, right? Tangent. Find the area of region R. You ready? Get set. Here we go. On our paper for full points, we're going to say the area of R equals the integral from left to right. Now, area R, is there a top minus bottom, or it's the curve? It's this curve minus nothing, minus 0. So we're going to integrate from this point to this point, which we know that's 0. And we need this function f of x. So we're going to find this answer. Go to the calculator, and we need this 0 here, so we're going to graph it. Oh, I really want to show you this. Keypad inside screen. I'm trying to just get the window to fit. Thanks for your patience, people. Okay, I want you to insert a new problem. Not a new page, but a new problem. Yay, I kind of got it. Is that it? Okay, so I'm done with problem 1, so I'm going to go to Doc, Insert, New Problem. So now I'm on problem 2. It's better. Trust me. Okay, ready? We got to type this all in. Here we go. Oh, that's not what I want. Oh my gosh, the most frustrating thing. One more try. If you're still watching, I'm proud of you. Okay, ready? Here we go. X to the power of 3 divided by, and the fraction button would work very well here also. That's not what I want, so I'm going to go back, minus, insert. You see that fraction button? It will help on this problem. And then x squared over 3, over to the right, minus, fraction button, x. You see this on a AP Calculus test, and you're like, yeah, this is what they do. They think of what's the most complicated thing we can test them on. Always double check before hitting enter. X cubed over 4 minus x squared over 3 minus x over 2 plus 3 times cosine x. Looks good to me. There we go. I'm going to move my label out of the way. And it does match what I see on my paper. And now we need to find that 0. So we're going to trace, graph trace. There's my spider. I already know it hits at 0. So I need this 0 over here, which I'm going to write it down, minus 1.373122. The more decimal places, the better. Now watch. Control, add page. I'm going to add a calculator now. Now I'm going to integrate. Okay, ready? Minus 1.373122 to 0. Okay, watch this. Thank you. I'm glad you're watching. I'm so proud of you. We're going to pick up the thing here in var. Do you see var? And then you hit X, and you don't have to type in that whole thing again. Isn't that amazing? Ta-da! Write it down. That's the answer. And we got to keep going. These are easy, but they take a long time. Okay, Number B. Find the equation of the line L if it is tangent to the graph of f at 0, 3. So here's what my paper looks like. That's exactly what yours should look like. Find the equation of L. Okay, so for an equation of a line, we need y minus y1 equals the slope times x minus x1. Do we have our x1 and y1? Yep. We have the y value of 3, and we have an x value of 0. So we know it's at the point 0, 3, but we need a slope of the tangent line. The slope of the tangent line is the derivative. So we're going to find the derivative of f because, if this is tangent to the curve, then their derivatives are the same. That's the definition of the tangent line. So we're going to find the derivative of f and then plug in 0. Could you do it in the calculator? Yes, actually, I think we need to do it in the calculator because this is a calculator problem. By hand, it kind of looks like those numbers will cancel, but they actually don't. So by hand, you would say something like this: the derivative of cosine is sine, and then you would plug in 0, right? But let's do it in the calculator. I'm sorry, this is a calculator problem. So we're going to go the derivative, calculus, menu, calculus, derivative at a point. We want to plug in 0. Okay. Oh, look. Look at that. We're just going to type in var. So we don't have to re-type it in because it's sitting in this graph right here. Okay. So the derivative of that at the point 0 is negative 1/2. Negative 1/2. So if we found f prime of 0, negative 1/2, which is now the slope of the tangent line, negative 1/2 x. Okay. At what ordered pair other than 0, 3 does the graph of the line intersect the graph of f? Okay, we learned in class today how to find, so we know it intersects here. So now we need to find this intersection point, which means we need to graph the line L in the calculator and then find the intersection point. So here we are, hit tab, and now we're going to do a negative 1/2 x plus 3. And there's our line, and thank goodness it looks just like the picture, so we're doing it right. We're going to find this intersection point. Menu, Analyze Graph, Intersection, Lower Bound, click, Upper Bound, click, and we see the intersection point is at 3 point. Oh, I think it's asking for the whole intersection. At what ordered pair? Okay, what does an ordered pair mean? An ordered pair means you need both of them. I am writing this down. Are you writing down the ordered pair? 1, 305. Okay, so when I switch to my paper, you can see that's the ordered pair where they intersect. Oh, that's it for C. Okay, now we can find the area of S, right? Area of region S, make sure you label it. So the area of region S goes from 0 to 3.389, and you have to do top, what function is on top, minus the function on the bottom, dx. Okay, you can use the labels that they've used in the question, but you may not make up your own, so you can't say F1 or F2. But what function's on top for the entire region S? The line L. So we can put L, or you can write out the entire line, and then f of x is in the bottom. So like I said, you can write it all out, and then we're going to plug this in the calculator and find the answer. All right, easy. Easy when I do it, yeah, and you're watching. But the key to this was that the equation, the derivative at a point at 0 was equal to the slope of the tangent line. The derivative at 0 was equal to the slope of the tangent line. Okay, I don't think I'm going to have time to write this all down and give you the answer. So you practice finding the answer in the calculator. And I'm going to try and get this answer down. I'm going to pause and then write it down. All right, here's the final answer, and my work shown just a little bit more clearly. Thanks for watching. If you have any questions, let me know.